Hi guys, and this is my pleasure to see you once again. Now just introduce myself. My name is Kirthic from secondary mechanical department in Amrita Vishwavidyapita, and I am the instructor of an welding technology in IWS Amrita, that is an Indian Welding Society of Amrita. So welcome for class. In last class we discussed the basics of welding, that is what are the classifications, what are the advantages, disadvantages, how many types of joints is there, like that. So in this class just we move on to the process which involve in the welding. So in this class we can discuss the process which involve in SMAW. So content of the classes are, here you can learn what's mean by SMAW, what are the advantages, disadvantages, why you are going for this type of process, and where this type of process are applying, that is applications, and what are the methods that you are using this process. So let's move on to the next class. So SMAW, that is then first we can see the expansion, that is an shielded metal arc welding. Why it's named as an arc welding means, in last class we discussed the classifications of welding. So I recall it once again. There are only two types, is fusion and pressure. Under the fusion is again classified into the 6 types like gas, arc, thermic, resistant, like that. So under the category of an arc, it again subdivided into 9 types, is known as plasma arc, carbon arc, this shield metal arc, etc. Tick, MIG, like that. So under the category of an arc welding, this shielded metal is one of the types, so it is named as a shielded metal arc welding. So first of all, before going to the process, you need some of the power sources required for this process. So in the bottom of the slide you can see the transformer. So transformer means it may be step up or step down. The power supply is mainly given by the transformer is maybe AC or DC, and current ranges should varies between 50 amps to 300 amps, and the power requirement should be less than 10 kilovolt, and it is in a single phase, but it depends upon the your requirements, that is it may be single phase or 2 phase or 3 phase, but it requires 50 Hz of frequency. So advantages going for DC is, so first of all we can see the disadvantages if we use an AC source. So disadvantage of if we use an AC source means it is an alternating current. The expansion of AC is an alternating current. So if we use an AC means the arc is not stable, because you can't see where the arc is producing, but the arc will be producing with somewhere between the metals. So if we go to for DC means, suppose your workpiece thickness is 25 mm, so it is very thick, so you can directly weld by using a straight polarity, that is by using a DC EN, that is the direct current electrode negative. So the electrode should be negative and workpiece is positive. Suppose your workpiece thickness is 5 mm, then you can directly use by using the reverse polarity, that is you can use the DC EP, that is the electrode should be positive and workpiece is been negative, that is then reverse of the terminals. So DC EP is a direct current electrode positive and DC EN is a direct current electrode negative. Suppose your power source is consists of transformer, it is a step down means then you can use the alternating current. That is, in this slide you can see the type of current that you are going to choose for the required power sources. So this transformer is step down, that is an alternating current. So you can use any kind of phase, that is an single phase, two phase or three phase. And suppose your transformer consists of a rectifier, so then you should choose your DC, that is a direct current, and here your power supply is maybe than a single phase or a two phase. And motor generators is you guys already know that it requires only DC current. So advantages. So why you are going to this process is, this process is very simple. That is, you can usually do this process in anywhere, in any place, and this process is very cheapest, and this process can be weld by any position. That is, you can weld in flat, horizontal, overhead, or as you wish. You can weld in any positions. So what are disadvantage means? This process is very slow because it is manual process, and once your electrode is finished off, you should take another electrode and fix it into the electrode holder, and then you should continue your work. So a lot of electrode will be waste during this process. So where these type of processes applying means, you can see this is your underground pipelines and railway tracks. In thermodrilling also is applying in railway tracks and automobile debris, and some of the structural members you have seen in roadside. That is, in some of lathe shop they will use this type of process and they will. So materials required for this type of process is, first of all, you need your power source, that is AC or DC, and you need your welding cables and electrode holder to hold your electrode, ground clamp, and welding electrodes. And again you will need for your safety, that for welding helmet, hand shield, protective clothing, chipping hammer. This and all is used for your protection. So these first five is used for the process, and next three, that is 6, 7, 8 is used for your safety precaution. So let's see the use of your safety. That is, it is first hand screen and goggles is used to protect your eyes. Gloves is used to protect your hands. Tongues is used to hold hot metal, because the melting temperature, when the electrode melts means it produces 1500 degrees Celsius, so it is very hot. So you should take by using these tongs. And chipping hammer, that is used to remove slag. And wire brush, that is used to remove your weld bead. That is, the weld bead is nothing but dust producing there. And stick clamp, that used to hold your workpiece. So in this slide you can see the entire picture. First is chipping hammer, second is gloves, head helmet, wire brush, etc. Electrode coating. So electrode coating is just an electrical insulators. That is, it prevents from short circuiting. See, these are your electrodes, and this gray area which is surrounded your electrode is nothing but the flux coating, and this is made up of some of chemical reagents that is surrounded your electrode. So what are the advantages of this type of graphite electrode means? It is very is less cost, and it carries a long life and also a long current, and this material is a hardened brittle. But disadvantage means it is a very low electrical resistance, and arc is formed is can't be controlled very easily. It is very comparatively difficult to control your arc. Classification of welding. So according to AWS, that is an American Welding Society, the electrode is classified into there are many classifications of welding. As the simple example is given us, for example, this is an best example, that is an EXX, that is it contains 4x. Some electron numbers is consists of 6x, that is E and 6x, the EXX, XXXX like that, and EXTX like that. So this is your primary example that I given here. So the first E stands for your electrode, and 2 and third number, and the second and third number stands for your tensile strength, which is measured in megapascal, and fourth one is your welding portion, where you are going to weld the metal, and the last one is indicates your flux coating, that is the chemicals region that surround your electrode. Suppose your electrode is named as E8013, then let us see, the E is your electrode, 80 is your tensile strength, 1 is your welding position, and 3 is your flux coating. See, this is your electrode, and this red area is surrounded by the is made of some chemical reagents. So this is your flux. This flux is surrounded your electrode. So now see the welding position of E8013. So just now I explained the third number, that is 1 is your welding position. So 1 means you can weld in any position, that is in all position, that in flat, horizontal, vertical and overheated, because there are only 4 types of welding position is there. The 4 types is flat, horizontal, vertical and overheated. So 1 indicates you can weld in any direction, that is any position you can weld. Suppose your electrode number is consists of E8023. See, E8023 means then 2 is your flat and then your horizontal, but it is only for your fillet weld, and the third is your flat, and fourth is also vertical down and all position. That is the vertical down means you keep your workpiece in vertical position and weld the workpiece from the downwards to upwards. And flux coating for E8013. See, so this 3 is your flux coating. Just now I explained what is meant by flux. The chemical reagents that surround you in electrode is nothing but flux coating, right? So so this 3 stands for flux coating. So the 3 is made up of titanium potassium. So these are your chemicals that you are using, that is surrounding your electrode. So this titanium potassium, the current can be given as AC, DC, EP, that is alternating current or direct current electrode positive. Suppose your electrode name is E8012. 2 means then you can use your titanium sodium, that is your chemicals you are using is titanium sodium, and the current can given as AC, DC, EN, that is alternating current or direct current electrode negative. So next is your electrode size, that is choosing of an electrode size. The choosing of electrode size, for the first main important thing is you should know what are the where you are going to weld, that is your welding position and flux coating. These 2 are very important, and how many amps, that is how many current that you should given for your electrode for generating on arc. Suppose your plate thickness is 4.5 and your electrode size B4. Let's say the thickness is taken in x-axis, and this ES, that ES is nothing but your electrode size which is taken in y-axis, and your plate thickness is 4.5 and your electrode size is choosing B4, then see this 4.5 and 4, then you should give 140 amps from the power source for generating an arc. The another example, suppose your plate thickness is 1 and your electrode size is 2, then you can give your 20 amps from the power source for the populating. So this is your block diagram of SMAW. See, this is your power source, is maybe AC or DC, and this is your positive terminal. This positive terminal is given to your electrode, and this negative terminal is given to your ground cable, that is given to an earthen material here. So it carries a negative current and this carries a positive current. So now let's move on to the process which is taking place here. Just now I explained what's meant by SMAW, that is just now I explained the expansion of SMAW, why its name is shade metal arc welding, etc. The another name of SMAW is an MMAW, that is manual metal arc welding or manual arc welding. Because it is a manual process, it is not an automatic process, so it is named as the manual metal arc welding. But mostly is another type basically called as stick welding. Why they called as a stick welding means your workpiece and the electrode should not touch each other. If the electrode touch the workpiece means then the electrode gets stick on your metal piece, so it is nothing but, so it for that reason is otherwise known as stick welding. So now let's now explain how an arc was generating between your workpiece and your electrode. So the electric current, that is you are given the power AC or DC from your power source, and the current was passing to the entire circuit that you have seen in previous slide, and arc is generating between your electrode and your metal piece. Okay. As now you are entering the process, that you are starting the process. First the electrode is disengaged, that is distinct as the shielding gas and provides some slag. And note that this electrode and an workpiece should not touch each other, that you can see in a previous slide. See, this is your workpiece and this is your electrode, and the gap between the workpiece and the electrode should be the 3 mm or 4 mm, because if the electrode and is touch the workpiece means that this electrode will get stick into the workpiece. So his name also called as stick welding. So again explain once again. So as the flux is disengaged, it produces a shielding gas and provides some slag, and this slag will provide from the weld area from atmospheric gases and any other oxides, that is experience from oxidation in simple phrase. And after the process is completed, the slag will formed on the surface of the workpiece, and this slag can be removed by your chipping hammer and can be go for an expose. So this is your entire picture of SMAW. See, this is your base metal, that is this is your workpiece, and this black color coatings are nothing but flux coatings, and this cylinder rod is your electrode, and now you are passing your DC or an AC current, so the arc is generating between the metal and an electrode. So this is your arc, see, and this arc is nothing but a crater, and will provide you with slag and also the shearing glass, and these shadow lines are nothing but your welded area, and this is in front, and this slag will prevent your weld area from the atmospheric gases, that is, it prevents from your oxidation. So these type of process are used to weld different type of metals. For some of you listed here, iron, steels, aluminum, nickel and copper alloys are been welded by using this process. And overview of this process is, it is a very simple technology, and this process is used only to weld for steels, and it requires a very high heating. So after completing all the process in your lab, then some of the steps that you should follow. So you are not supposed to carry any inflammable materials, that is like firecrackers, matchboxes, etc. inside your lab, and use the tongs to hold your hot metal, because after welding in the base metal, that is your workpiece is absorb too much of hot, so you should handle your hot metal by using of tongue, and don't throw your electrode tongues in your ground floor. So thank you so much, and in next class we can discuss the process which involve in GMAW, that is then gas metal arc welding. That is another type of arc welding is there. So we can discuss in next class. Thank you so much, and peace.